Currently, the only thing keeping it in place is that notch and general friction fit, but it's pretty well in place. I'm not worried about it going anywhere. However, I do have to worry about things like hurricanes and when this boat is in motion. So I'm going to be putting some stainless steel lag bolts through the back fiberglass into that 2x4 support, which is integrated as part of this rear deck board. And so that's going to hold the back in. The trickier bit is going to be mounting things to the front, so I'm going to have to manufacture some brackets. Now, if I had a unified design from the very beginning and knew exactly what I was going to be building, I would have arranged things so that these screw holes were closer to these uprights and supports in the bench, because that's pretty much the only thing I have to attach down to, unless I decide to try to drill some more holes into the support boards. So my plan here is to manufacture some type of a aluminum bracket that will go across here and attach into something here. And probably the same thing on that side. As a matter of fact, I might do it on that side first. I'm a little worried about the area where the drawer goes in. I have this aluminum, 1/8" aluminum bar stock, which I'm going to be trying to make brackets out of. So it looks like I'll be able to put a piece there and not have it interfere with the drawer. And I hope that the drawer will have enough clearance on the bottom here, I think it will, for me to be able to put this guy down here, replace that washer, and essentially have, you know, a piece of bar going from that guy to this bracket and not interfere with the drawer moving in and out. So I've made this thing here tight enough that I can't get a bracket in between the drawer and this piece of cedar, so I'm going to have to mount to the fiberglass that's past it. So once I get past this drawer front, I can mount in there underneath the drawer rail area with no real problem. Safety goggles on, breathing mask on. Let's burn through some aluminum. Remember, don't pick up that end with your fingers because it's hot. Because I cannot attach to the wood, I want to spread this force out over a decent amount of that fiberglass. So I'm going to do about 3 inches here, and we'll cut that something like that. So while you're waiting for this thing to cool down, as long as you have gloved hands, you can file it off a little bit. Make it just slightly less sharp. So that's the raw material for one bracket. No fancy angles, anything like that. I think I might weld it like this. I've made some marks so I remember which two pieces are welded together here, and because this butt joint is going like that, that's why I have that line at the top there. Of course, once I weld it, it's going to expand the joint, and I'll have to grind down the flat bottom, and it'll probably also expand the metal a little bit and bend slightly. So I'm not going to be drilling any of the holes on this until after the welding is done. In one sense, the bracket over on this side is going to be pretty easy because I'm basically going to have a flat piece here, and it's not going to be quite all the way to the end there, so I'm going to cut it, say, about there-ish. And so that flat piece will begin there. But then there'll be a piece here, and it can't go straight out. It's going to have to be at an angle. So I'm going to have an angled weld to the bottom of that piece. Okay, we want this piece of aluminum to go through the center of that thing there, as opposed to just barely touching the edge of it. So we're going to have to angle it like that till it hits the center. And then I need to transfer that angle from the boat onto the piece of aluminum by scribing. So that's essentially the angle I want. So this is a straight line, it's just on an angle to the edge of the metal. So let's see how that goes. The only trouble that presented was my guard was hitting the vise here, so I couldn't get in as far as I wanted to. As soon as I changed the angle, it worked out pretty well. These two pieces will be welded like that. And I'm sticking it out. This little cutoff is a little bit shorter than that piece. I could have trimmed this piece to be the same size, but I'm just going to have it stick out a little bit on both the left and the right. This side over here will be filled in with the welding. That side over there, it'll possibly just stick out a little bit, or I might grind this side down a little bit later after I get the weld, because after I do the weld, I'm going to have to do a lot of grinding, at least on the two back sides to make them flat. This guy is going to be there. That guy will be welded to it like that, and then a hole will go through there. And this should be the super easiest bracket of all. Basically just need a piece that size and then a piece that comes up here a little bit. Here's the material for the three brackets I'm going to fabricate. This one's simple 90-degree angle bracket. You know, you could buy something off the shelf for that, but since I'm making these other two, I figure I might as well make this one since I have the aluminum bar stock. Also, it'll give me a chance to dial in the settings on my welder for 1/8 inch aluminum, and hopefully, you know, if I mess it up, I can chop a couple more straight pieces real easy and try again. This guy here is just another 90-degree angle bracket, but it's kind of an offset one like this, so it'd be harder to buy something like that. And this guy here would be really hard to buy at the specific angle you wanted. I'm using a C-clamp to hold this guy in place. I'm just going to tack that little corner right there. Then I'll move the C-clamp over and tack the other corner before I try to do the actual weld. Obviously, I don't know what I'm doing here. So that tack worked much better than this one. Of course, when your electrode looks like that, it is time to grind. Alright, you can see here why I'm going to have to grind that flat down when I'm done welding it, because I made a gymongous bead on that sucker. Also, be sure to be wearing your heat protective gloves because this guy is quite warm when it comes off the welding. I've unplugged the welder because for this interior bit here, that interior corner, I need to get that electrode a lot closer to the corner than I can with it just sticking out a tiny little bit there, so I need to push that out. Now normally you wouldn't want your electrode out anywhere near that far because it's going to hit your puddle and all your gas bubble, your argon is going to be gone. But I have the advantage here of these two pieces of metal holding my gas in there, so it can only escape out to the two sides. So I'm actually going to get this at about the angle I want to hold it, and I'm going to use this ceramic as a guide, so I can just drag this along like that, and I'm going to position this where it's at the appropriate length to be really close to my workpiece, but not touching it, hopefully. And then lock that in place, hopefully. Of course, you have to make sure that the angle you're holding this is exactly right. Now I got that too close, so let me see if I can push it in a little bit. Okay, so holding at 90, I tightened it up. Now when I turn it off of 90, I can put that thing in there and just drag it along, and hopefully it'll stay at the right distance. Also critically important that you attach your grounding rod to your workpiece, because without that, this whole process really doesn't work well. It's not perfect, but it's not bad. Alright, that's not a bead I would be embarrassed to have visible on my boat. Of course, I need to grind down that corner there where my tack went horribly wrong, and I'll have to grind the backs flat, but I believe that is going to work pretty well. And as liquid as all that was in that gap, I'm pretty sure it penetrated quite deeply into the aluminum, so I'm not too worried about weakness in the metal there. I have a bench grinder and I have an angle grinder, and in this situation I'm going to try the angle grinder so I can try to get this a little more flat. Nice thing about that, grinding that down, is I can see that the weld penetrated quite nicely because there's no obvious spot where these pieces of metal butt against each other as I grind that down. I melted that inside corner a little bit with my tack, melted this corner a little bit with the tack, but that interface there looks pretty nice, and this is a place where a wire brush will be nice. I think I'll hit that once with the wire brush. Normally I would not use gloves around a power tool like this, but with those wire brushes So, 90-degree angle weld, about the second easiest weld you can do, but I feel confident I have the settings on my welder set up correctly. So let's do the more custom brackets now. My last inside corner weld went so well, and since the electrode's already set up for 90-degree inside corner work, I have just fixed this place in with a C-clamp, and we're going to just weld that thing straight through without tacking it first. Alright, now I'm doing the back kind of flat surface of a butt joint. I've pulled the electrode way back inside so that it'll stay within the gas flow, and it's time to weld that little bead there. We're going to try to go light on the filling rod here, because I'm really just trying to connect those two pieces of metal without making the fillet in there. I turned my amperage down to 110, so it took me a little bit longer, but it gave me a little bit more control. I still blew out a little bit of aluminum right in that corner there. Some of that's from the inside corner, some of that's from the outside corner here. So I just don't have that surface there, so it's made the joint a little bit weaker because it's reduced the amount of metal I have in. But other than that, it's going to work pretty well, I think. So I'm using just a generic C-clamp. It's not a welding clamp, and you can tell it's because it's painted. And normally you wouldn't want paint on these because when it gets hot it melts and can run and transfer to your workpiece and so forth. Alright, so this guy's a little bit uglier than that guy, but from a surface area standpoint it has a little bit more aluminum in the fillet there, so it's probably a slightly stronger joint there. It occurs to me that if I cut another piece of aluminum off and, welded it in here, I could strengthen this connection to that piece. But realistically, this is going into that piece of fiberglass. The weld is going to be stronger than the couple of screws into that fiberglass. So I need to fixture these guys like this. And I have these magnetic welding 90-degree corner angles. The problem is aluminum isn't magnetic, so I can, kind of set that thing down there to hold it in place, sort of. But it doesn't really fix the aluminum in place. If I were to put a ground clamp on that, it'd flip the whole thing off. And I don't really want to weld right on top of my vise anyways. So I was going to put this thing on this way, but then I realized, and that's kind of clamping at a weird angle, then I realized if I put the butt joint up this way, I could clamp it there and have a 90-degree angle for clamping. So I've decided to change my butt joint so that it's butting up like this. Okay, I got that clamped in there. Because my welder's already set up for a flat butt joint, I'm going to weld this little bit and that little bit and try not to weld it to my clamp. Take it off, move it around, weld the center bit. So here's the rear of the weld. Why, it's almost like practice is making me better. Alright, I have this thing fixtured so it's kind of a V shape down. I have my electrode pulled out so I can get deep into that guy. Probably going to blow out this back corner regardless of what I try. Let's give this a shot. This is the visible side of the weld here. Alright, so after a little bit of grinding so it'll sit flat, there is my custom bracket. With the exception of a little blowout in that corner there, I'm pretty darn happy with the welding there. 6.24 ounces. I wonder if maybe I should have bought stainless steel, because these guys don't weigh anything. The hard part will be getting the nuts and washers on the other side of those screws. Since I have to disassemble it to take it to the lake, I believe I'm probably just going to leave it like this and put those guys on after I disassemble the sucker. I need this chamfering bit to be able to get in there with my drill, so I'm going to start these holes about there. Of all the brackets, I'm most proud of this one because it has this weird angle that you just couldn't buy commercially. Alright, with that bracket and this bracket here, this guy is nice and sturdy now. And with those brackets holding that guy down, the bench seat is finished.